Hi, this is Math 1350 and this video is over section 1.3. We're going to be looking at how to get information from graphs as well as how they relate to equations. First, the domain and range. It's probably one of the most important things because every graph you're going to have a specific domain and a specific range. And you can figure these out by looking, but there's going to be some things that sometimes you need to know the equation in order to know for sure. The domain is the set of all x values that are possible. The range is the set of all y values that can be obtained from the function. Okay, and we see at the graph the range for this goes from, we measure that in the y, so y1 to y2 here, and for the x domain we measure it from x1 to x2. Okay. And we have to make sure we know whether x1 and x2 are in the domain, and same with y1 and y2. Alright, so the domain is all x values of the graph. In this example, we're going to find the domain and range. Wrong. Our x goes from -3 to 1. Okay, so -3 to 1 on the x-axis, so from here to here. Okay, now is -3 and 1 included? Well, 1 is, that point is dark, so we put a bracket. -3 is not, so we put a parenthesis. Okay, that's the domain. For the range, the lowest value is -4. Highest value is 0. Now, are these points included? Well, we can see this point here as well as this point here are both included in the graph. So -4 will have a bracket. Now, this point over here is not included, but this point is. And so we would say that is also included. At least from what I can tell. Alright, so let's graph now this one. -3 to 3. And we're only going to graph within that region because it gives us this. So at -3, when we square it and we subtract 1, we get 8. At -2, we square and subtract 1, we get 3. At 0, we get -1. Actually, let me make that closer to the rest of the lines. Okay. And then at 2, we'll get 3. At 3, we'll get 8. And yeah, we could have graphed x equals 1, I just didn't. So we get this. Okay. So our domain is actually pretty easy here. It's what's already written. So -3 to 3, including -3 and 3. Our range, the lowest point is -1. And it goes up to 8. Okay. Now, when you have a restricted domain like this on the graph, it's not going to always follow the same normal domain and range we would see with a quadratic function. You know, a normal quadratic function, the domain is all real numbers, and the range goes from the lowest point to the highest point. In this case, because of that restricted domain, it changes things. Right. But don't assume that just because we see this that is automatically the domain, and you'll see why in this example. That's just basically telling us to make that the window that. Right. So we'll graph some of these. So let's start with -10. So we have negative square root 25 minus 75, and we see we have a problem. So we're going to end up with a negative 50. Okay, and so that's not in our domain. All right, so let's go in more. Let's do -5. I meant -10, but 10 looks the same. So -5. We get negative 25 minus 25, which is negative square root 0, which is 0. So -5, 1, 2, 3, 4, 5, you're at 0. Okay. And so let's then look at positive 5. And you're going to see pretty much the same thing, 25 minus 25, and so we get -0. Okay. So now let's do a number in between, which the obvious one is going to be 0 itself. And so we get negative square root 25, which is a -5. Okay. And so the graph is going to look like this. Your domain is from -5 to 5. That should be a bracket, just didn't look like it. Range goes from -5 to 0. So when we solve equations, and we can set equations equal together and or set functions equal together and find solutions, the solution is going to be where those functions cross. Right? That's when these functions have an equal sign or are set equal together. Right? When the two functions are made into an equality, well, you're looking at where one is less than the other. Right? Then the solution isn't just where they intersect, but it's also where the region that satisfies the given inequality. So for instance, f of x is less than g of x. So at these crosses, that's where they're going to be equal. Okay, where is f of x less than? It's going to be less than here. Okay. In this case, because it's only a less than sign, the points where they cross are not part of the equation, so we would say the solution is from A to B and not including A and B. If, however, I'll put it this way, this is with the less than sign. If, however, let's say we're looking at, I'll do it this way, f of x less than g of x. If we're looking for f of x less than or equal to g of x, then those cross points are also included, and it's going to be A and B. Okay. If we're looking for f of x greater than or equal to g of x, then the region is going to be the opposite side, and it's going to be here, where g of x is I'm sorry. Not there. That's not what g of x is greater. It's going to be where f of x is greater. So here and here. Alright. And so we will write this, and let's assume that this goes out to infinity just to make it easier to write. So it's going to be from negative infinity to a, including a, and union with b to infinity. Okay. And then if it's a greater than or equal to, a greater than sign, not a greater than or equal to sign, then a and b won't be included. All right, so let's say we have negative 2x plus 3 equals 3x minus 7. Right. We want to look at the graph. So I'm actually going to graph these on Desmos. Right. And so negative 2x plus 3 and 3x minus 7. And we see these cross right here at 2, negative 1. Okay, so the solution is 2, negative 1, because that's where they cross. Okay. Now we're going to look at, I'm going to do C first because that has the same thing. We're going to look at when negative 2x plus 3 is less than or equal to 3x minus 7. Okay, so 2, negative 1 is a part of the solution. Okay, which one is that? That is the red one. Now we want to see where that red one is less than. Well, it's less than when x is greater than 2. Alright, so the solution here, and I'm going to graph this. So this is 2, negative 1. So one line, 2 line, and everywhere here is where it's greater. The 3x minus 7 is greater. Okay, and so we will write the solution as 2, including 2, to infinity. Now let's look at another one. So this is going to be x minus 2. And this is going to be 4 minus x. So quick sketch of this. We have a line coming down, red line coming up. That point is 3, 1. Now we want to know when x minus 2 is greater than 4 minus x. So x minus 2 is red. So red is greater than on this side. Right, and so we will say the solution is when x is greater than 3, and it's not going to include 3. So 3 to infinity. Okay. Next thing we're going to look at is increasing and decreasing. When we're going from left to right, so as we read a book, we go from left to right. If the function goes up, if that y value goes from one point up to another point, then you have increasing. And if the function goes down, so that y value goes down from one point to another point, then you have decreasing. And of course the other one here is if that y value doesn't change, then it's constant. Okay, so is it going uphill, downhill, or the straightaway? All right, so let me do a couple examples. So we'll make a couple graphs here. Okay, so first graph, we'll do a linear line. This is increasing. And it's increasing from negative infinity to infinity. Okay. We can do one that's a line going the opposite way. This is decreasing. And it's decreasing from negative infinity to infinity. Linear lines do one of three things. They increase, they decrease, or they're constant, and they remain that way the whole entire time. We can do quadratics. This part here, let's just do an I here, is increasing. And we're going to call this A. So it's increasing from negative infinity to A. And on the other side, it's decreasing. And it's decreasing from A to infinity. Okay, I don't put any brackets on these. Okay, and notice this has a vertex. That is a maximum. So let's do quadratic that's normal kind of one we see. Here we are decreasing first, and we'll go okay and call this A. Decreasing from negative infinity to A, and increasing from A to infinity. And here we have a vertex that is a minimum. Okay. Do a couple more. We'll do a cubic one. Okay. We have increasing, decreasing, and then increasing again. Okay, so we'll call this 0. We'll call this A. Right, so it's increasing from negative infinity to 0, and from A to infinity, it's decreasing from 0 to A. And we'll do one more. It's going to be a fourth root. The fourth power. So we're going to call this A, B, and C. That's these points. And so it's increasing, decreasing, increasing, decreasing. So it's increasing from negative infinity to A, and from B to C. it's decreasing from A to B and from C to infinity. Okay. Okay, now in all of these graphs, what do we see here where it changes? Well, when it goes from increasing to decreasing, there's always maximums. If it goes from decreasing to increasing, it's always a minimum. And so we call those local maximums, local minimums. A local maximum appears when it goes from increasing to decreasing. And so in that region, that area, it is where the function is highest, right? Maybe not the highest overall, but highest within that region. And that's a maximum. A local minimum is when in that region the function is a minimum, even if it's not a minimum overall. Okay, so I'm going to bring up Desmos. I'm going to bring up a different way with this. Or I can have it right there off the side and I have to shrink my page. So x cubed minus x. We'll zoom in. And so what we're going to do is say where, I'll do it this way. Say where there is increasing, say where there are maximum minimums. So there's points we need to know, and luckily Desmos will allow us to pinpoint these just by clicking. Okay, and they're always clickable on because they're either x-intercepts or they're min and maxes. And so we can say here, this graph is increasing. I'm going to do a different color. Increasing from negative infinity to -1. And this is this section here. I'm not sure if you can see the cursor in the video, but it's the section here where it goes up from negative infinity to 1 to that -1 on an x-axis, and we always read it across the x-axis. And then it continues to increase. So actually, you know what, I went up to the intercept, but I gotta go all the way up to the maximum point. Right, so it's negative 0.57, I'm around to 7. Okay, so it goes all the way up to here. Okay, that's where it reaches a maximum. So then it's a maximum at, I'll do it this way, at x equals negative 0.577 with value 0.385. And then we have decreasing all the way down through that intercept, all the way down to the minimum point. So it's decreasing from negative 0.577 to 0.577. Then we have a minimum at x equals 0.577 with value negative 0.385, and then it's increasing again from 0.577 to infinity. And then notice x-intercepts, -1, 0, 0, 0, which is also the y-intercept, and 1, 0. And then just to kind of, since we've already introduced this, domain, all row numbers, range, all row numbers. And then move my graph over here. Put on the side. So let's do the next one. X square root of x minus x squared. I'm going to zoom in. A very tight one here, but notice there is a maximum here. We have a 0, 0 point, now 1, 0 point. Okay. So here it's increasing from 0 to 0.75. Then it's decreasing from 0.75 to 1. So there's a maximum at x equals 0.75 with value 0.325. Domain goes from 0 to 1. Now we can plug in these values. If we plug in 0, we get 0 square root of 0, which is 0. If we plug in 1, we get 1 square root of 0, which is 0. Right, so those values are included. And then the range, it's 0 and to your maximum point, 0.325. And that's included too. Next one. One minus x squared divided by x cubed Notice these are hard to see sometimes that we have a maximum here, but we do. I mean, it's going up here and then it decides to go back down. It passes 0, now it's going back towards 0. Same with on this other side. So the max is here and here. We have intercepts here and here. And so we'll start off with, from negative infinity, it's increasing. And if we want, we can take a quick look and see it's just going down to 0. There's no more x-intercepts. Start crossing it, just going to 0. Okay, we have a horizontal asymptote there. We'll eventually get into those. So it's increasing from negative infinity to negative 1.732. And it's decreasing from negative 1.732, and it continues to decrease to the asymptote. Right, so to 0. Doesn't increase at 0, and we can't say it increases or decreases through 0 because of that vertical asymptote at 0. Right, and so it's then decreasing from 0 the maximum point 1.732, and then it's increasing from 1.732 to infinity. Okay. And so we have a max point at x equals negative 1.732 with value 0.385, a minimum at x equals 1.732 with value negative 0.385. Okay. We have asymptotes at x equals 0, your y-axis, as well as at y equals 0 for your horizontal asymptote. And we have domain goes from negative infinity to 0, and then from 0 to infinity. Range, there is no y values that we can't get out. We can get 0 out. We have x-intercepts. The lowest part on the right side is lower than the highest part on the left side, so it's all real numbers. And then we have x-intercepts of negative 1, 0, and 1, 0. All the information we can to obtain from the graph or from equations where we're trying to graph it. Okay. X to the fourth minus 2x to the third minus 11x squared. Oops. Meant to hit the 1 twice, hit the negative sign twice. Alright. We can see this goes pretty low and for some of these, so we're going to do this. I'll scroll in as we need to. Alright, so intercept there, lowest point, maximum point. Okay, I'll just go from one side over to the next. So it's decreasing from negative infinity to negative 1.71. So we have a minimum at x equals negative 1.71, value equaling negative 13.61. It's increasing from negative 1.71 to 0. So we have a maximum at x equals 0, value equaling 0. There's also your y-intercept. And an x-intercept as well. And then afterwards is decreasing from 0 to, and then that's where we have to scroll down to get the other point, to 3.21. I'm sorry. Yeah, it's decreased from the. So we have a minimum at x equals 3.21, value equaling negative 73.32. Then it's increasing from 3.21. Now scroll back up, and it's increasing up to infinity. Okay. Domain, all real numbers. There's a polynomial. Range, the lowest point on this was negative 73.32 to infinity. Then I mentioned one x-intercept. The other ones are here and here. So negative 2.460 and 4.460. Tons of information you can find out just from looking at the graph. Right, I'm going to stop the video here. I'll finish this because we got two more things to go through. We got system symmetry to go through, which is just 2 pages, I know, but then we have the difference quotient, which would take a little bit more explanation. Alright, so I'm going to stop here. See you in the next video.